As we were talking about the backpropagation multi-label neural network in the previous part, so it is basically based on the traditional multi-layer feed-forward neural network. So in the neural network, as we know, we have input layers, we have hidden layers, and as well as we have output layers. So in this kind of network, the hidden layer is fully connected with the input and the output layer, but it does not have any connections with the outside world. And the goal of this algorithm is to optimize the pairwise ranking error. Next, let's talk about the evaluation metrics that we have used for this project. So the important thing to note is the fact that to note from the graph we have developed for our data set, and this that we have seen is that uh, our data is pretty much skewed, which means the ratio of the number of commits which are labeled as toxic for one or more of such levels to another to the number of comments which are non-toxic is very low. Like there are only 10%, about 10% comments which are classified as toxic as per the as per our analysis we did using those graphs. So taking accuracy as an evaluation metric would provide invalid measures for our model. For example, even if we design a basic classifier model which classifies every comment to be non-toxic, the accuracy score would be 90%. For this reason, I have used Hamming loss and log loss as an evaluation matrix, which works fine even for the skewed dataset. So, talking about Hamming loss, a Hamming loss is characterized as a ratio of wrong output labels to the total number of labels. So, for example, you have 100 labels, and out of that, if 5 are wrong, then Hamming loss would be 5%, 5 by 100. So Hamming loss for a multi-label problem can be implemented by assigning equal weight to each label, and that way it is weighted Hamming loss, and then combining the predictions of each label to produce the final loss value. Next, I've used log loss. So before talking about log loss, let's see the comparison diagram for the Hamming loss. So as we can see from this graph, the Hamming loss for the binary relevance multinomial naive-bayes binary relevance method with multinomial naive-bayes classifier is the lowest, and it is almost similar to the to our label power set multinomial naive-DB. Next, log loss. So the log loss analyzes the accuracy of a model by penalizing the false results produced. Uh, it is suitable only for the problems having two or more labels. For calculating it, each label must be assigned a probability rather than simply giving out the most favorable label. So log loss works by considering the probability of each label and not favors any one label. Here is the log loss comparison, and from the log loss comparison, it can be seen that binary relevance multinomial doesn't work that well as compared to the Hamming loss. Thank you. That's all about it, and bye bye.